Hi guys, let's talk about ionic bonding and ionic compounds today. So seawater is made out of salt, and those are cations and anions combining together. And when we get rid of the water, evaporate it, turns into sodium chloride. So these are all the salt flats you see along the bay, San Francisco Bay. You see these beautiful salt flats. They're just evaporating the water, and then the sodium and chloride come back together into a crystal. So we're going to talk about electrical charges of an ionic compound. Remember, ionic compounds have a positive or negative charge. And when we combine cations and anions together, we're forming an ionic compound. So even though they're made out of ions that have charges, when they come together, they have to be electrically neutral. So there has to be no charge overall for the combination of those things together. So here's an example of bromine gas. This is this orange gas. This is, remember, a halogen. Aluminum is a metal. And metals and nonmetals together are going to form into an ionic compound. So it makes aluminum bromide. So one aluminum, 3 bromines. Each aluminum has a +3 charge. Each bromine has a -1 charge. So we need 3 of those to balance out the charge to make 0. This compound has no charge to it overall. So this is the way it works. We have sodium with 1 valence electron. Chlorine has 7. One of those valence electrons is going to jump over there to chlorine and complete this outer shell. And then this shell, this part's going to go away. So afterwards, sodium has a complete octet. So does chlorine. It becomes chloride. It looks like after they lose, this is isoelectric to neon. Chlorine looks like argon after it loses. And so now they feel stable. So you have a Na plus has a full octet, chlorine minus, chloride has a full octet, and they feel like the noble gases that they resemble. They're called isoelectronic. And then sodium +1, chlorine -1, so they're going to go together in a ratio of 1:1 to make a 0 overall charge. So this is ionic bonding. I need you guys to be able to draw this when we do quizzes and tests. So chemical formula shows the number and kind of atoms that are represented in something called representative unit, the smallest possible combination, and the ratio of those ions when they go together. So the formula unit is the lowest whole number ratio of the ions. Like I said, sodium, there's 1 of those and 1 chlorine to make sodium chloride. It's a 1:1 ratio. So here's sodium chloride. Here's the crystals that are formed from the San Francisco Bay, and water's evaporated, and then the sodium combines with the chlorine that becomes chloride. That crystal looks like this. It's a 1:1 ratio of the sodium pluses and the chloride minus ions to make electrically neutral solid there. And it looks like this. Chloride -1, sodium +1, and so it's a 1:1 ratio. So see if you could try potassium and oxygen together. Look at your periodic table. Try magnesium and nitrogen and see what you think what their ratio would be when they come together in an ionic compound. And we're going to have to be able to draw that, just like I showed you on the first one here, sodium chloride. So potassium is got 1 dot. So hopefully try this out before I'm showing you the answer. Oxygen has 6 valence electrons. So to fill these 2 holes in oxygen, we're going to need 2 electrons. So we're going to need to have 2 of these potassiums to make that happen. So there's going to be 1 electron jumping over there from that potassium and 1 jumping over there from that potassium. When they're done, K is a +1 because it lost 1 electron. Oxygen got 2 electrons, so it's a -2. So it's going to be potassium oxide. And so it's a ratio of 2 potassiums, you see there, 1 oxygen. So let's look at magnesium. Magnesium has 2 electrons in its valence. Nitrogen has 5. So how are these going to go together to make everything balance out? To make it work, we have 3 holes here, 3 holes here. So we have 6 holes total for the nitrogens. to make the valence fill up. So 2 can come from this guy, 1 more can come from that guy, and then 2 can come from this guy, and 1 can come from that one. So overall, each magnesium lost 2 electrons, so it's a +2. Each nitrogen got 3 electrons, so it's a -3. So the ratio of this goes together is 3 of these have to balance out 2 of those. So it's a ratio of Mg3 to N2. So that's the formula for that. So what are 3 properties of ionic compounds? After we make them, like the sodium chloride from the San Francisco Bay, these are the properties. They're crystalline solids at room temperature. You know that. You put table salt on your food and it's a solid. They have really high melting points, so it takes a lot of energy to melt these things. So that takes a lot of energy. They have really cool shapes and they look beautiful. I love crystals. And there's all different kinds of crystalline solids. So I'll just show you some. The way they go together with their ions gives them different shapes. There's that fool's gold we were talking about earlier. And so we're going to skip over this. I don't care so much about coordination number, but when you put ionic compounds in water and you put the electrons can actually move out of the water in through wires, and you can push electrons one direction or push in the other direction depending on the chemicals you have in the water. And ionic compounds will let electricity flow through the liquid there because they have a plus and minus charge, so they'll let things run through there. So ionic compounds can conduct electrical current. That's why when people get struck with lightning, the electricity runs through their body and goes to the ground and they get electrocuted because we have lots of different ions in our bloodstream. We're mostly made of water. And here's our quiz, so let's see how you do. Good luck. Which one's right? Look at your periodic table, pause this for a second, and see if you can make the right formula. Good luck. Alright, if you look at it, you'll see that this one, oh, sorry, I read that wrong. This one is incorrect because K is a +1 and F is a -1. So you need only 1 K and 1 F. So this formula is not right. I should have read that correctly. Incorrect. Ionic compounds can conduct an electric current when? When is that true? I showed you that little picture of the electrons moving around in the wire. Alright, here we go. So it can be when they're melted or dissolved in water. So both of those things can be true. You can have electricity run through ionic compounds. Last question. At room temperature, our table salt is what phase? Hope you remember that we eat solid, crystalline, solid table salt. Alright, I hope you learned a lot from this. This section is also important to learn how to draw ionic compounds and how electrons move from one element to another. Alright, talk to you soon. Bye-bye.